I'm Rick Swigert. I'm Dean of the Herff College of Engineering at the University of Memphis. Over the next few months, I'm going to be taking you on a tour of the Herff College and introducing you to a number of our faculty and students. Today I'm standing outside the Engineering Technology building, which houses our Biomedical Engineering department. What is biomedical engineering, you might ask? Biomedical engineering is a broad field that focuses on improving health with the use of engineering principles. For example, designing new implants for those who suffer from hip fractures, developing tools that help detect heart problems through sensing electrical signals from the body, discovering drugs to fight cancer and other illnesses, just to name a few. Come along and let me show you more about the Biomedical Engineering department here at the University of Memphis. Memphis is a leader in the biomedical industry, which employs close to 57,000 workers across more than 1,000 establishments, representing over 10% of the employment in the region, more than 30% higher than the national average. According to the U.S. Bureau of Labor Statistics, biomedical engineers have excellent job prospects and earning potential. The aging population and focus on health issues will increase the demand for better medical devices and equipment. In keeping with our mission, research continues to be at the forefront. Let's meet a few of our outstanding researchers.
Hi, I'm Warren Haggard. I'm a professor in biomedical engineering. I've been at the University of Memphis for 9 years. Here today to talk about undergraduate research. I'd like to introduce two of my colleagues involved with undergraduate research. Dr. Amber Jennings, who is a research assistant professor at the University of Memphis in biomedical engineering, and Monica Ralston, who is an undergraduate biomedical engineering student working in our lab.
We work with chemical signals that prevent infection. And particularly, Monica is helping us evaluate the compatibility of these signals that prevent infection with bone cells.
I work as an undergraduate research assistant in the Biomedical Engineering department. I work with testing biocompatibility of chemical signals that disperse infections via the biofilm. So with these chemicals that are harmful to bacteria, I'm testing to see their effects on bone cell growth that we don't want to harm. So we run assays and we monitor with microscopes, and we pay very close attention to the effects of these chemicals on the cells that we don't want to inhibit growth.
Bone infections are devastating infections. They're not a high occurrence, but when they do, they're a high economic cost and a high quality of life cost to the patient themselves, because it may take a minimum of 6 weeks to abate the infection. It could take 6 months to abate the infection, and many times the implant has to be taken out and a new implant put back in after the infection has been treated. So let's say you had a functioning knee implant and then you have an infection, and suddenly your knee implant, even though it's been re-implanted, they put a new one in, you've lost half the function. So now you've got a stiff knee, not a knee that was functional. Our research is trying to prevent that by using these chemical signals, these chemicals, to specifically cause the bacteria not to adhere to the implant surface and create this infection. And by doing so, we hope to lessen the number of infections and lessen this devastating disease when it does occur.
We're working on different methods of delivering these signals, and some of them can be pretty challenging to deliver, but we're working on ways to coat implants with these signals, or have a separate drug delivery device that would release a steady amount of these signals. We've also, they could be injected. And the particles that she's evaluating are part of a smart drug delivery system where the clinician could, once these things are implanted, could deliver a stimulus to make that implant release the drug at a specific time so that it can prevent infection or deliver growth factors for tissue engineering. So there are many possibilities for these smart delivery systems,
including delivering these chemical signals at specific times when we might need them to help keep the bacteria from adhering to a surface. In this research, not only are we collaborating within biomedical engineering, we're collaborating with our colleagues in electrical engineering. They're the ones who are applying the stimulus for us. So.
You will be proud to know that Herff graduates are prepared and ready. Here's the Biomed program by the numbers. The Herff College of Engineering is home to the only undergraduate biomedical degree program within 200 miles. Currently, there are 141 students enrolled in the undergraduate program. 90% of undergraduate students have either secured positions in biomedical-related industries, have been accepted into graduate schools, or have secured other employment by the time they graduate. Biomedical engineering is home to 44 graduate students. I hope you enjoyed your tour of the Department of Biomedical Engineering today, and also meeting some of our faculty and staff. Dreams are becoming a reality here at the Herff College of Engineering thanks to our dedicated faculty, staff, and students. But we couldn't do it without you. Thank you for your support and for taking the time to visit the Herff College of Engineering. I look forward to meeting with you again next time as we visit the Department of Civil Engineering.